Okay, we are moving into section 3.6, and 3.6 is just a discovery section. It discovers the derivative of sine and cosine. So we're also going to start, and there's no homework with that section, so we're also going to start 7.1. So, because it's sine and cosine, we want to go back to trig and look at those two graphs again. So sine x, if you remember what it looks like, let's see, sine x, we'll do a zoom trig. And remember, you see two cycles of sine there. Sine starts at the origin, starts on the axis, goes up, makes that cycle. So we're seeing two cycles here. I'm going to change the window so that we only see one. So it's going from 0 to 2 pi. Alright, there's your sine graph. So, the things to remember, the period length was 2 pi. The amplitude, remember, was the number in front of sine. So it's a 1 sign here, so the amplitude goes up to 1. And down -1. Started on the axis, went high, back to the axis, min, back to the axis. And then it continued on. Okay, so amplitude 1, period 2 pi. Let's look at cosine. Let's see, I'll turn that one off just by hitting enter there. Cosine x, so all we'll see is cosine, one cycle of it. So there's cosine, starts high, comes to the axis, goes low, back high, and it's going up to 1 and down to -1, so same amplitude. Starts at 1, hits the axis, -1, hits the axis. Remember, that was that bowl shape. And then it continued. Back down on each end there. Okay, what we want to look at, first of all, is sine's derivative. So if we type sine in and n derivative of sine, so we want to discover the derivative, that'll be d dx, of the sine function. So we're going to graph both. I'm going to turn this one off because I don't want cosine to graph, and turn sine back on. So I want sine to graph, and then I want to see its derivative. So I'm going to go n deriv of sine x, comma x, comma x. Remember, that'll graph all of the derivatives for every x value. And I'm going to make this graph fat by changing that. And now let's see, graph. There's the sine graph. Remember, these max and mins are going to be zeros. Okay, what graph is that right there? The one that it just graphed. Should look familiar. It looks just like cosine. And it is. So the derivative of sine x came out to be cosine x. Alright, how about the derivative of cosine? Could we get lucky and have it just be sine? That would be awesome. Let's go. Let's see, turn off sine. We're done with that one. Turn on cosine. Turn off that n deriv. Actually, I'm just going to go up and change that sine to cosine. I'm looking for the derivative of cosine. So cosine's going to graph, and the derivative of cosine. There's cosine, starts high, does its thing. Here comes the derivative. Ooh. Sine didn't do that. Okay, took care of that. This should look familiar though. It's almost sine, it's just sine flipped over. Do you remember what makes the graph flip over? That was that negative amplitude. So, and I'll show you real quick. If I turn sine back on, I'll turn cosine off so it's not distracting. So there's sine, and now we're going to look at the derivative of cosine, and you can see it's just this graph flipped over. And if you remember back to trig, the negative amplitude made it flip over the axis. Oh, made a nice pair of eyeballs. Alright, so the derivative of cosine is negative sine, because it makes it flip over. Alright. So, what happens if I change the angle a little bit? Let's look at the derivative with respect to x. Let's try sine 3x. Okay, we already know the derivative of sine is cosine. What is this 3 on the angle going to do to my derivative? I'm going to use the graph to tell. So we want sine 3x. I don't want cosine, I want the end derivative of sine 3x. Insert 3. Make sure I've got it. Sine 3x xx. Okay. Okay, remember that 3 on the angle just makes it shorten up the period, so I've got more cycles of it. Okay, still looks like a cosine. More cycles of it, but it's a lot taller. And if you look, sine went up to 1, this derivative's going all the way up to 3. So where's that 3 amplitude coming from? Probably the derivative of the angle. What's the derivative of 3x if we use our little power rule? Derivative there is 3. So it looks like the derivative of the sine function is actually the cosine of 3x. Never change the angle, but then I have to multiply by the derivative of the angle. And to make sure we don't confuse that this is not a multiplier on the angle, that it's the function that's multiplied by 3, we should float that 3 to the front. 3 cosine 3x. And let's just see if our conjecture is right. If I go to y equals, and if I graph 3 cosine 3x, and I'm going to change it to the little circle thing that runs along the graph, there, that'll run a circle along it. I'm going to turn sine off, because I just want to compare the derivative of sine and with what we think is the derivative of sine. There's the circle one going. So that's 3 cosine x that's graphing. Now here comes the derivative of sine 3x. And you can see it's fitting perfectly. So with trig functions, you're going to have to multiply by the derivative of the angle. And let's just check and make sure that the same thing is true with cosine. The derivative of cosine 2x, we think would be, first of all, the derivative of cosine is negative sine, so we think it's going to be a negative sine. Always keep the angle the same, never change it. And we think it's going to be times the derivative of just the angle, and the derivative of 2x is 2. If I bring that 2 to the front, times it by the negative 1 that I've got there, I've got negative 2 sine 2x. And if we get this to match the end derivative of cosine 2x, we're going to write down the rule. So, clear. So I want to compare negative 2 sine 2x with the end derivative of cosine 2x. I want those to be the same. So I'm going to go back up. I'll change this one to the fat one. I want the fat one to graph first. Oh, I went too far. Then I'll change this one to the circle one. Okay, graph. So, and then there goes the circle right on top of that. So if you followed all of that, we now have our derivative rules. Okay, you're going to get your blue sheet for this too. So we've got 2 new derivative rules. We had the power rule, and now we've just got 2 more. So the rules we're going to add on to that sheet are the derivative with respect to u, and I'm going to choose not to use the x, and it's okay. The sine of some angle u, the derivative is cosine u times the derivative of u, so I'll call it u prime. So this is the rule that's going to go on your blue sheet. And then the derivative of a cosine function of some angle u is the negative sine of the angle times by the derivative of the angle. And you're going to get a lot of practice with this in the next section. So that was section 3.6. It was just discovering these 2 new derivative rules. All right. Moving into 3.7, we're moving on to our 4th derivative rule. But before we get to that, we need to talk about composite functions. Composite functions have a function within a function. Okay, and what we have to be able to do before we can do this next derivative is pick out the inside function and the outside function. The inside function is, if you typed it all in, it would be the first thing that like a calculator would have to work out. So it's the first, what's the word I want to use? The first operation. The outside function is the second operation done. So inside and outside is what we need to be able to pick out. So let's go with first example here. If I give you a function sine of x to the 5th, you have to be able to see this as 2 functions. The outside function and the inside, out and in. The inside function is the first thing that the calculator would have to do to work this whole thing out. Well, the calculator would have to know the value for x, and it would do this to the 5th power thing first. So your inside function is the x to the 5th, and your outside function would be to take the sine ratio. So there's your inside, there's your outside. If I had y equals 2x plus 1 cubed, outside